Listen to part of a discussion in a geology class.
So, we've talked about the ecology of grasslands, areas of the world where rainfall is not enough to sustain thick forests, but enough to prevent desertification. That is, the spread of desert lands. I want to turn now to a discussion of a different kind of biome, or natural community, known as the tundra. Okay, so as you know, the tundra is a region of the Arctic, lacking in trees, bushes, and covered for the most part in short vegetation, well adapted to the inhospitable conditions. In fact, the word tundra comes from a Finnish word meaning treeless plain. I guess you could say that's a pretty accurate description of what you find there. Flat land and no trees. Today, I'm going to ignore the region known as the alpine tundra, which is found at higher elevations in mountainous regions all over the world. This has similar characteristics to the Arctic tundra, but also enough differences that I think we can justify spending a separate lesson on its main features. So, to understand the life systems that exist in the tundra, you have to understand that below the surface is a permanently frozen layer of soil. This is the layer called the permafrost. Perma from permanent, in other words, permanent frost. Anything that grows there has to be able to adapt first to this impenetrable floor of frozen soil. What do you think could be one adaptation to this situation?
Well, plants would have to have short root systems because the roots wouldn't be able to penetrate the hard layer.
Okay, that's right. So what about any rain that falls, or water from melted snow in the summer? Where does that go?
Well, I guess it can't go anywhere if the ground is too hard to soak it up and too flat for it to drain off.
Right. So what you get is a kind of shallow, waterlogged top layer of soil, which freezes and thaws as the seasons change from winter to summer. So, on the surface, marshes form, and in low-lying areas and depressions, small lakes and ponds are common during the periods when the ice and snow melt. This poorly drained water on the surface provides moisture for plants. In fact, there is relatively little annual rain, so this marshy, wet ground is important for plant growth. So what about the soil itself? What would you guess is the nutrient value for living things?
Well, since it's very cold most of the year, wouldn't that mean that dead organisms break down slowly? So, wouldn't that mean a low level of nutrients for plants to use?
That's absolutely correct. Just as with the moorland biomes that we were discussing last week, mineral nutrients are in short supply because cold, waterlogged soil slows down the rate of decay of dead plants and other organisms. So the plants that do exist have to adapt to this special environment, a poor, shallow soil and a bitterly cold climate with strong winds. You mentioned the short root systems, but what other kind of plant characteristics do you think might be useful in a region like this?
Well, given the strong winds that blow, wouldn't it be useful to be short? After all, tall plants with shallow roots would be easily blown over.
True. And to add to that, of course, the short roots can only maintain short plants. So that's another reason why the plants are very short. Another adaptation is that the plants cluster together in groups, often taking advantage of depressions in the ground to avoid the strong winds, and that helps them to resist the cold temperatures. Then, also, the snow itself helps them survive in these conditions, since the snow effectively insulates against the bitter cold. When the snow melts in the spring, of course, the plants have a ready supply of moisture, making up for the low levels of precipitation in the region. So, when the summer finally comes, what you get is a time of compensation, you could say. As you know, the summer sun never sets at these high latitudes, so the plants get sunlight for 24 hours a day. It's as though they work overtime to produce essential sugars and the other substances necessary for plant functioning from this continuous light energy. It's like the sudden arrival of summer, as if the vegetation as well as the insect and animal life were hurrying to take advantage of the relatively short time before the onset of the next winter.
What is the discussion mainly about? Why does the professor not want to discuss alpine tundra? According to the professor, what features are typical of tundra regions? According to the professor, why do tundra plants often cluster together in depressions? In the discussion, various facts about plants in the tundra are mentioned. Indicate whether each of the following describes tundra vegetation.